So next, are there any questions online? Okay. So next, we're going to have Luigi Degni from the Italian group. He is a PhD student in our lab, in the model lab, and he is going to show you some data about some next development of what we want to do later or in the future, some future directions about this line of research on Q-trigger decisions.
Now? Okay. What? Now? Yeah. Okay, I'm still Luigi. I will present you just a behavioral experiment of my PhD project. So this has been conceived to be just a sort of sequel of the modern project, because we will try to understand the future directions of the project. So this is just a brief summary about the project. We aim to investigate the role of the motor system in Q-guided decision-making by using always the same or similar experimental paradigm, so namely the Pavlovian to instrumental transfer paradigm. But at the end of the project, we started asking if there were any still open questions about Q-guided decisions that we wanted to answer. And maybe the most important was about the adaptivity of this behavior. So we asked, is Q-guided decision-making advantages or disadvantages for people? By using this experimental task that you have seen before, we were not able to answer this question for several reasons. Maybe the most important is that we worked always on a value-based decision, so decisions based on the value of different alternatives. But these alternatives that we have seen before had always the same motivational value for participants, because they were previously tailored for each participant. So like the stickman, participants always equally like the two options. And moreover, the participants had the same probability to win rewards. So if they press the left response, which lead them in this case to the pizza, or if they press the right response that lead them towards the hamburger, they always had the same probability to win. Okay, so there wasn't any advantageous choice in these cases, because if they only press the left response or the right response, or if they equally distribute their responses between response 1 and response 2, in general, they will always win more or less the same amount of rewards. So in daily life, the situation is quite different, because often when we have to decide between options that have different value for us. For example, in this case, the participant, the stickman, equally likes the two options, but they have different probability to be win. So there is an optimal choice and a suboptimal choice. Optimal choice means that it is related to choosing the alternative that makes you win the greatest amount of reward. Like in this case, the pizza, because if participants presses the right button, he will win the pizza in the 70% of trials. The suboptimal choice is when you choose the alternative that makes you win the lower amount of reward, like in this case, the hamburger. So in the literature, it's known that people tend to match the ratio of their responses allocated to a specific response to the ratio of rewards won when they choose their alternative. In other words, if participants can win in the 70% of trials when they press the button related to pizza, they will press that button in the 70% of trials. And this is considered as an optimal strategy to act, the optimal way to decide. Okay, so we asked, and this is the aim of our study, if motivational cues, like you have seen before, can not just drive decisions, but they can also drive decisions toward suboptimal rewards, suboptimal choice. So can motivational cues alter reward matching? Can they favor suboptimal choices? This was our main question. Like there is always the same example, which is related to the McDonald's sign. We are very original. So there was if a person is walking on the street and he sees at the McDonald's sign at a wall, I don't know, can this McDonald's sign drive people toward hamburger, even if people know that the response toward the hamburger is less likely to give them the reward? What we expect to find is that, yes, McDonald's can drive them toward that response. So if before there was that matching, so the 70% of responses were allocated toward pizza and 30% of responses toward the hamburger, here the percentage of responses toward hamburger is increased to 60%. It's just an example. But the probability to win that outcome is still lower. So if participants increase the responses toward a reward, a response that is not so likely to make them win, what happens? It happens that people often not win because they are increasing a suboptimal response, a suboptimal choice. So the losing of the matching of the 70-30 that we have seen before is making humans suboptimal, it's leading people to win, to choose a response that is not so winning. So specifically, we have three hypotheses. The first is just a confirmatory hypothesis about reward matching. So the 70-30 percentage of responses that you have seen before, can we see this in the absence of any cue? So without any cues, can participants understand that there is an optimal strategy to act in the environment? Then we have to prove or to test if motivational cues can alter this matching. And the third hypothesis is just a consequence. So can motivational cues not just alter reward matching from 70-30 to, I don't know, 40-60, for example, but they can also reduce the general amount of rewards. So can we state that this possible alteration of reward matching is even making humans suboptimal? So to answer this question, we recruited 26 participants that performed a modified version of the PT task that we've seen before. So the first phase is a Pavlovian learning phase, and is exactly the same as you have seen before. There is just a simplified version of this slot machine because we want in the future to test psychophysiological measures, and we need a black and white background. So in the upper screen of the slot machine, the conditional stimulus appear. Here is not a color, it's just a fractal stimulus. Then after 3 seconds, the rewarding outcome can appear on the lower screen. So we have 3 conditions, 2 conditional stimuli that led to respectively to 2 different outcomes, equally liked for participants, and a third control stimulus or neutral stimulus. So a stimulus that a CS minus is called so-called CS minus because it's never paired with any outcome, so it's not motivational for participants. Okay, so this is maybe the crucial phase here because it's quite different from the instrumental learning phases that you have seen before this phase, because here it's more like a reward matching task. So like in the other experiments, there is a sort of go signal. So 2 levers appear on the left and on the right of the slot machine, response 1 and response 2. And each response led people toward one or the other rewards that were the same of the Pavlovian learning phase, so outcome 1 and outcome 2. But here, and this is the difference, one response leads people to go to win the outcome, the response 1, in the 70% of the trials, while the other, the response 2, leads people to win just in the 30% of the trials. Okay, so there is an imbalance in the probability to win when they press the left response or the right response. So here we expect to find the reward matching. So people should increase during this phase the percentage of responses allocated towards the outcome 1 compared to the outcome 2, to the response 2. Then participants perform the transfer phase, which is exactly the same of the other experiment. So there is motivational cue, conditional stimulus that appears on the upper screen of the slot machine, simultaneously with the appearance of the two levers on the left and on the right of the slot machine. Here, they can press still the left or the right response. And importantly, the first important factor is that they can see at the reward that they are winning, not like before. They can see what are they winning. And the second crucial factor is that the probability to win the left or the right outcome is exactly the same of the previous phase. So the optimal strategy should be here to press again the 70% of the trials response 1 and in the 30% of the trials the response 2, totally ignoring the cue. Okay, so here we had 4 conditions. 3 conditions that were the same of the popular learning phase, and a 4th control condition, which is a no cue condition because no cues were presented on the background. So it was exactly the same of the instrumental learning phase. The CS minus and no cue conditions are control conditions. So we expect to find if people can continue to acting optimally, they should continue pressing the response 1 in the 70% of the trials and the response 2 in the 30% of the trials. This is the optimal strategy. When they see they look at the CS1, they should increase the percentage of responses 1 because this cue was previously associated with the outcome 1 that was also won through the response 1. So this cue should increase the percentage of the response 1 as compared to the response 2. But we don't have any strong hypothesis about this because we start from a 70-30% of responses. So even increasing the response 1 to a 80-20% of rate, for example, we cannot think to find a difference in the number of rewards won. So we cannot state if this cue can make humans suboptimal or optimal. Maybe the most important cue here is the CS2, because the CS2 was previously paired with the outcome 2. And the outcome 2 was the outcome won through the response that was less likely, had a lower probability to give them the outcome. It's complicated, but even if people increase the percentage of response 2, it's exactly as the McDonald's sign. So if they increase the percentage of responses toward responses 2, they should act suboptimal because they are increasing a response that give them the rewards just in a 30% of the trial. Okay, so let's go to the results. This is about the instrumental learning phase or reward matching task, the phase in which we expect to find the learning. So the participants should learn that the response 1 is the more optimal for them and the response 2 is less optimal. They should increase the percentage of response 1 and reduce the percentage of response 2. Looking at the left plot, there is the red line always corresponds to response 1, the blue line always corresponds to the response 2, while the dashed line corresponds to the perfect matching, the perfect strategy. Okay, so here we can see that in the first, this is a trial by trial plot. In the first 30 trials, participants cannot discriminate between the two responses. They cannot understand which is the optimal decision for them. Then they start to increase the percentage of response 1 and to reduce the percentage of response 2. So they are learning that there is an optimal response and a suboptimal response. Looking at the overall results on the right panel, there is a significant effect. So they have understood that the response 1 is more optimal. They have increased the percentage of response 1 and reduced the percentage of response 2. They are acting optimally. We can state that people show reward matching as we hypothesized. Then we want to study the main aim of the study. So the study is studying if the conditional stimuli and specifically the CS2 can change this reward matching, can make humans suboptimal. The red line always corresponds to response 1, blue line to response 2. There is an ANOVA on the factor CS by response. So we have the 4 conditions that I showed you before and the 2 responses. Response 1, which is the high probability response, and response 2, which is the low probability response. The optimal way to decide is like the dashed line. So to have a greater percentage of response 1 compared to response 2. And here we see that in the presence of the control cues, CS minus and no Q, people act in this way. So they act optimally. They still know that there is an optimal strategy to act, which consists of increasing response 1 and reducing response 2. And the same, more or less, happens for CS1. Maybe it's just increase this difference, but I said before, we don't have a strong hypothesis about this. What does this happen? It's like a specific PT, what we have seen before in the other experiments. Our hypotheses are about the CS2, because here we can see not just a reduction of the reward matching. There is a total shift of the responses. So there's an increased response 2 compared to response 1. What we say is suboptimal, hypothesize that is suboptimal. We can say this, that motivational cues are altering reward matching. But this is not enough for us, because we also have to demonstrate the cues are making humans suboptimal. So they should lead people to win a lower amount of reward. We have to demonstrate this. So we also counted the general amount of rewards won in each condition, independently of the type of response, independently of the type of rewards, because they equally liked the rewards. And we can see that in the CS2, so the condition where the reward matching was no more present, people are winning less rewards. So this really allows to state that cues influence is suboptimal, is making human irrational. Okay, so we confirmed all hypotheses. We are lucky. And so we can say that motivational cues are making humans suboptimal. This has several implications, because it's probably the first evidence about this possible suboptimal influence of cues on decision making. So we are planning to perform other experiments to explore more both the marketing context, for example, in which it will mean that an advice can drive you towards a product that is not the best for you, for example, all in clinical context for the gambling disorder, in which you act suboptimally because you perform you make decisions which are not the best for you. This is the basis of the gambling behaviors. So I want to leave you with our conclusions and the future directions of our study, because we have other questions that we want to answer in my PhD in the next years about why does it happen, who is more affected by this behavior, because there is a great inter-individual, there are many inter-individual differences in this tendency to be affected by suboptimal cues. And the last, how does it happen? And this is the best link to the modern project, because we hypothesize a possible role of the motor system even in this behavior. So maybe the motor system can be involved in this suboptimal influence or not. So thanks to everybody, and thanks to my colleagues and friends. Hello. Questions? Yeah. Yes. Yes, this is exactly what we wanted to explore, because if we cannot work more about this, the money, the prices, so we had to find a more complex factor to work on. We also can modify the quantity of the rewards, 3 chips versus 1 hamburger, for example. But we wanted to work more on a factor that can be more implicit for participants, like the probability, because there is the learning of probability. If you work more on the money, participants don't have to learn the money; they just see at the price. So, but the implications are surely about this, about the marketing for these reasons. Other questions, even in Italian from the students? Yeah. Okay, it's more your field than mine. I don't know. I can expect to find the same results, but maybe it's not so strong, probably. Maybe more science. Yeah, a very interesting question, because you are not losing anything. You say it's the other person that lose the rewards. Yeah, but I think that maybe the principle of the advertisement is to be, is the theory of mind, is to be more in the person that is acting in that moment. So I think to find the similar result for this reason, because they work on these processes. They think that you can I don't know, you can think like the person that is acting in that moment. Maybe, but we can investigate it. The partnership could continue with. Other questions? Fine. Thanks.
Okay. Thank you, everybody. So this is the end of our morning session. We're gonna have a lunch break now, and we'll meet back here at 2 with some more exciting talks. Okay. And